Good evening, children. So, who are there? Mic is on. Yes. I'm sorry. I got late. Late. I came home late. Late month. Good evening. I sent a message that I am going to start the class at 6:45. Right. So we have some 2-3 minutes. Let's wait. I was on the way when it's around 6:30. Vipmal is there. And who else? Last day we couldn't have the class just because of the internet problem. These dialogue people have some big problem now in their internet services. Kavisha, good evening. Uh, they say it's because of it's a technical problem. They say some frequency overlapping with India. So something they can't solve. Uh, so let's see whether what we can. So there's nothing I can do, right? If the internet connection goes, right? But I'll try to get another internet connection. And the other thing is, let's see if we can start the class physically, right? In about in next 2 weeks. අපි පොඩ්ඩක් බලමු ළමයි. එහෙම ආණ්ඩුවෙන් තාම කියන්නේ නැහැ නේ හරියට දෙයක්. කිව්වොත් අපි ටක් ගාලා කවස් පටන් ගන්නවා. ඊට කලින් කරන්න බෑනේ. අනිත් එක මේ දැන් මේ ඉන්ටර්නෙට් ප්‍රශ්නක් තියෙනවා. එහෙමත් තියාගෙන අපිට ඔන්ලයින් කිරීමේ ගැටලුත් තියෙනවා. ඩයලොග් එකේ ලොකු ප්‍රශ්නයක්. ඒකවලට විසඳ ගන්න අමාරුයි කියලා කියන්නේ. ඉතින් පන්ති පටන් ගන්න බැරි වුණානේ නේ. පටන් ගන්න බැරි වුණා මේ ක්ලාස් එක මේ දාලා තිබුණා ලයිව් ස්ට්‍රීමින් එක පටන් ගත්තේම නැහැ. data හොඳටම ඊයේ ක්ලාස් එක කර ඉන්නකොට හොඳලාට පැය දෙකක් විතර ගණන් පස්සේ ටක් ගාලා මම මේ බෝඩ් එක පැත්ත හැරලා මේ පැත්ත යනකොට ක්ලාස් එක එන්ඩ් වෙලා. ඒ කියන්නේ සිග්නල් නැතුවම ගිහින් බින්දුවටම දැන්. අදත් එහෙම වෙන්නේ නැහැ. එහෙම වුණොත් මම ආයෙ ටක් ගාලා දානවා. හොඳේ. සිග්නල් ලොස්ට් වෙලා මේ ක්ලාස් එක නැවතුනොත් මම අපහු මේ ඔයගොල්ලෝ මෙසේජ් එකක් දාලා හරි විනාඩි කිහිපයක් මේක ලේසි නෑ හොඳේ. ඔබ අර මොනවාද මේ ඔය සාමාන්‍ය ටීචර්ස්ලා කරන්නේ Zoom එක වගේ ටක් ගාලා පටන් ගන්න බෑ. YouTube එකේ ඊට වඩා තාක්ෂණයක් ඕනේ වැඩ උනේ. ටිකක් වෙලා යයි. එහෙම මේ ටක් ගාලා යන්නේ හිටියොත් මම කියන්නේ නැතුව you wait. Okay, I send a message and start it again. I have to start from the beginning. Right. Now, so that's how things are. And this is Sri Lanka. Okay, 6:45. We can start the class. We were doing a straight line. The ways that we write the equation of a straight line. We said there are several ways. Number one, your Euler method, the familiar one is to write the equation in the form y plus mx plus c. You do this when mc gradient and intercept of the line are given. We will write the equation in this form. Abhinda, good evening. Then we said the general form of writing the equation. General form of writing the equation of a straight line is ax plus by plus c equals 0. A linear equation of x and y. This is not a method. This is like theory, right? This is a general form of equation of a straight line. Then we learned about two more methods of writing equation of a straight line. The next method is if you are given a point in the line, say x naught, y naught, and its gradient m. If you are given the gradient and a point, so you can write the equation in the form y minus y naught divided by x minus x naught equals the gradient, right? Another way of writing the equation. And we learned another by last week, not last week, the week before, right? This time you are given 2 points. Here, a point and the gradient. Instead of the gradient in this, you are given another point. X1, y1, and another point. Instead of the gradient, it's x2, y2. So you can start it the same way. 1 point is given here. You can take 1 point and with the left hand side, you can start the same way. So which will give y minus y1 over x minus x1. Now the other side, instead of the gradient, you are given another point. But this is sufficient. This is sufficient to find the gradient of the line. 2 points, you have 2 points. Instead of m, here we will find the gradient. y1 minus y2 divided by x1 minus x2, right? So like theorem 1, theorem 2, theorem 3, theorem 4, we learned on the equation of straight line, and two more methods that we have learned today. Okay, two more methods. This is the fifth theorem. We discussed up to this by last lesson. Theorem 5. This time the data. Are you are given. This time you are given. This time you are given two intercepts, A0 and 0B. Y-intercept and the intercept, x-intercept, right? If you are given the x-intercept and the y-intercept, you can write the equation in the form x over a plus y over b equals 1. You can write it in this form. That's what we are going to prove now. Okay. Theorem: if the x-intercept or x-intercept simple a and y-intercept simple b of a straight line L are given, its equation may be written as if a and b are given, you will write it in the form. Here we wrote x over a plus y over b equals 1. So that's the theorem, and let's prove it. Proof: proof is somewhat similar to the previous proofs that we have done, right? For previous theorems. So this is a point is a, coordinate a0, this point is b, this coordinate 0b. Let's take some point in the line. negative. it is valid for any positive or negative value, but for the proof, it's better ignore it the other way. For a proof, it's not good to do a complicated diagram. A0 and 0B, right? We'll take some point in the middle, not in the middle, it can be anywhere. For convenience, I'll take it somewhere here. R with coordinates x and y, and I lay a normal from R onto x axis. So the base is some S. Okay. Now we are going to use. Can you give some idea? What are we going to use to prove this from this diagram? Lamai, Avisha, Abita, Vimal, and somebody else is there. No name. Basically, what are we going to use? I don't need a full proof. I just give one word. In one word, things we are going to use. What do you think? Any idea? Very much similar to the previous proofs. No response. It's something very easy. We are going to use the similarity of these triangles. Two similar triangles. From the similar triangles ARS and ABO. From similar triangles ARS and ABO. So we can say y over, or I like RS over BO equals SA over RS, yeah, SA over OA, isn't it? RS is Y, BO is simple B, SA equals A minus X divided by OA is A, right? So let's cross multiply and simplify a bit. You'll get AY equals AB minus BX. Take this to the other side. BX plus AY equals AB. Right? Now divide either side by AB. This is our target. That's the destination. Divided by AB, you get X over A plus Y over B equals 1. Okay, a very easy proof. I give just a simple, single and simple example. Nothing like much serious problems you can see from this. You just take it down and answer this question. Find the equation. Okay, we can go to the final. This theorem number 5. There's only one more under equation of a straight line. We finish this quickly and then go to that. Find the equation of the straight line that passes A minus 3 0 and B 0 4. Kakak ada kata lawan? Oh, itu kali lagi nak kalau kan? Oh, dia kali sih. හරිද ළමයි? Did you write the answer for this? A is minus 3. E is 4. So write it in this form. X over A plus Y over B equals 1. To write it in minus 3, we will multiply it by minus 12. Minus 12 will give what 12 maybe. That will give minus 4x 3y equals 12. So take this to this side, 4x minus 3y plus 12 equals 0. That is the answer. Right. Then shall we go to the next? Last method, last theorem of equation of the straight line. Theorem number, this has to be 6. This has to be number 6. Theorem number 6, this is in the syllabus, right? This theorem is also in the syllabus, but I know in many places this theorem is skipped, and in the exam also very rarely they ask from this theorem, but we can't skip it, right? I can't give a guarantee that they are not going to ask a question in 2021. So we have to prepare for that also. So this is the theorem, the normal method. Normal method. Right. This time the data are these. You are given there's a straight line L. There's a straight line L in the Cartesian plane. There's a straight line L in the Cartesian plane, and you are given from the origin, you are given the perpendicular distance d. So it's equal d. This is given. The perpendicular distance to the straight line L from the origin. It's given, and further you are given the inclination of this, the normal. Normal. Say with the positive side of x-axis, say it's alpha, right? If alpha is the inclination of this normal from the origin to the straight line, and d is the perpendicular distance from the origin, right? So d and alpha are given. Now you can write the equation of this straight line as x cos alpha plus y sin alpha equals d, right? So that's the sixth theorem, and the last method we are learning under the equation of a straight line. So we write it if the perpendicular distance d from O00 to a straight line L, and the inclination alpha of the normal from O00 to the straight line to L with the positive side of x-axis are given the equation of L may be written as x cos alpha plus y sin alpha equals d. Okay, so these are the data. The straight line L, distance from the origin, straight line L, distance from the origin, and the inclination alpha. Those things are given, right? Okay, let's prove it. So you will write the equation in this form. So we prove it. This proof is bit different to the proofs that we have done before. There's some difference. Its appearance is also somewhat different to the previous with cos alpha sin alpha. It's different to the methods we have seen earlier. Proof. Anyway, we'll do the proof. Again, I'm saying we draw the diagram for the easiest proof, not making things complicated for ourselves. So this is the straight line L. You are given the perpendicular distance. You draw normal. This distance is D. It's given. So this point is some A. The base of the normal, say it's some A. It's OD is given, and also this angle alpha. These two things are given. Now this is what we do for convenience. The general point we take somewhere here. Take RXY. මෙහෙන් ගන්නත් පුළුවන් අපි ඉතින් කට්ටකමට වැඩේ අමාරු කරගන්න නැතුව ලේසි වෙන we will take it somewhere here, right? And from the general point we lay a normal onto x-axis. say RS. Take a general point. General point RXY in the line L. Construct. This is a construction. Construct number one. The normal RS. The normal the perpendicular line RS from R onto x-axis. From R onto x-axis. Right? And there are more. Then from S, from the base of this normal, we lay another normal to the existing normal. From the base of this normal, we lay another normal to the previous normal. Okay? Say the base is T, so ST normal. Right, then then construct a normal ST from S onto OA. Right, then another one from R, we lay another normal to this normal. Say from RST, say RP. Make a Q के this is Q. RQ. RQ, then QT. From Q onto QT onto OA. Then another normal RP. RP from R onto QT. Onto QT. Okay? Now things are settled. Now we can proceed. You are given this angle is alpha. Now look at this. The proof is easy after doing all these, all the construction, right? This angle is alpha. So this is 90 minus alpha. This will also be alpha. And the coordinates are x and y, right? So like this distance is x and this height is y. So we want to show that x cos alpha plus y sin alpha equals b. Right? Now look at the diagram. You can easily see that OT length, this length is x, this angle is alpha. So the OT length is equal to x cos alpha. OT length is equal to x cos alpha. Then here, so we want to show that x cos alpha plus y sin alpha equals b. X cos alpha plus y sin alpha equals b. This part is equal to x cos alpha. Now it's sufficient to show that this part is equal to y sin alpha. And it's very easily seen that here from this triangle, this height is y, this angle is alpha, so PR is equal to y sin alpha, right? By a triangle, make that from triangle OQT. Make a from triangle PQR. PR equals y sin alpha. But PR is equal to PA, okay? But I mean PA is equal to PR. Therefore, TA is also equal to y sin alpha, right? This is y sin alpha, so is this y sin alpha. Now, OT plus TA equals B. OT plus TA equals B. OT. OT we found that equals x cos alpha, right? X cos alpha plus TA, we just found that it is y sin alpha equals B. And that's the answer. Hmm? That's the answer. That's the proof. Okay, now ලියා ගන්නකො. හරි. මේවා අහලා ගන්න නෑ ගොඩාක් කාලෙකින්. එහෙම කියලා මට ඔයගොල්ලන්ට මේ අතාරින්න බෑ. ඔක ලියා ගන්න පොඩි එක්සැම්පල් එකක් දෙන්න උත්තර. හරි. The question with my කලින් theorem එකෙන් කලින් මේ ඕක prove කරන්න බැරි. කලින් theorem එකෙන් මෙහෙමයි ඔය මේ ගොඩක් ඒවා එකකට එකක් සම්බන්ධයි. හැබැයි මේකයිලත් මම වෙන්නේ කලින් theorem එකෙන් කරන්න නම් මෙතනක දානවා b cos alpha रीसेट करते हैं ගන්න බැරි කමකුත් නැති වෙයි. හැබැයි එහෙමයි මම දැන් අර දැන් අද අපි කරපුවා මුලික කරපු theorem එක මේක කලින් theorem 5th is connected with theorem 4. හැබැයි මෙහෙමයි. අපිට අපි ඔක්කොම theorems ඉගෙන ගන්න ඕනේ. ඒක මතක තියාගන්න. කොහොමද එකකට එකක් කනෙක්ට් කරන්නේ? මොකද වෙන්නේ? data වල හැටියට දීලා තියෙන data වල හැටියට අපි දන්නේ වලින් කට් කාලා දානවා. හරියටම ගැලපෙන්න. right? අපි එකක් මතක තියාගෙන එකෙන් අනිත් ඒවා කරගෙන යන්නේ නැහැ. එකක් විතරක් ඉගෙනගෙන මැක්කා වගේ ඒක දාන්නේ නැහැ හැමදාම. දානක් හදානකොට you see that you want to write the equation of a straight line and you check for the data that you have. Upon that you decide you have like 5 options. Which one to use? This is another option, right? මේක දාන්න පුළුවන් තැනට මේක දානවා. proof එක කොහොමද ඔය එකකට එක proofs නම් එකට එකක් interconnected. Right? Eighth, you must learn this separately. අපි ඒක සම්බන්ධ කරගන්න නේද proof එක කරේ. Okay? දැනගෙන ඉන්න ඕනේ මේවා එකකට එකක් පාවිච්චි කරන්න. මේ දැන් අපි ඇත්තටම හරියටම වෙනස් ඒවා පහයි කිව්වේ with the general method there are 6. You should learn all these 6 methods. Okay? All the 5 methods and the general form. And to select what to use. You should be able to choose what to use. What to use to get the equation of a straight line upon the data that you have about the straight line. Right. Now, examples. The perpendicular. The concrete example, the perpendicular distance from 0, 0, 0 to the straight line is 7. The normal. From 0, 0, 0 to L makes an angle at 30 degrees with the opposite side of x-axis. Find this, write down the equation. Find the equation of L. Example number 2. If P minus 3, 4 is the base of the normal from 0, 0, 0 to the straight line L. Find the equation. Find the equation of L. L, right? The straight line L find positive side of y-axis by alpha, right? By alpha. Ini by alpha. The normal distance. Four zero zero L is 4. Find the equation of L. හරි කරගෙන යන්න බලන්න. කරගෙන යන්නකෝ බලන්න. මම වෙලා දෙන්න. මම ලියනවා පේන්නේ නැද්ද ළමයි? ඔය ඉන්ටර්නෙට් ස්ලෝ වුණාම තමයි එක වෙන්නේ. පේන්නේ නැද්ද ලිත්මල්? ආයි යන්නේ විදිහ මේ. උඩ තියෙනවා මම ආයි දෙන්න. Shit. Mana manga ID. Okay, now we try it. Ini kita dengar kerjaan dulu. Can you see the answer for the first? It's like as I said, a concrete example, a direct one, a straightforward question. Answer number one, d equals 7, alpha equals 30. So the equation is x cos alpha plus y sin alpha equals d, that is x cos 30 plus y sin 30 equals 7. Cos 30 is root 3 over 2. Sin 30 is half. So you get like root 3x plus y minus 14 equals 0. So this is the answer for the first. දෙවෙනි එකට අඳින්න වෙන්නේ. Minus 34 is the base. Minus 34 is the base of the normal. Say point A, B is the base of the normal from the origin. This angle is alpha. This is the angle with the positive side of x-axis, inclination of the normal. This is the normal. This angle, say if it is alpha, by definitions in trigonometry, cos alpha is, you know that d is equal to 5, right? I write d here. D is equal to the distance between 2 points, square root of 3 square plus 4 square, that's equal to 5. 3 minus 0 square plus 4 minus 0 square, it is equal to 5. So cos alpha is equal to, the way we define things in trigonometry, cos alpha is equal to minus 3 over 5. And sin alpha is equal to 4 over 5. So we can write the equation in this form. X cos alpha y sin alpha equals d. X cos alpha is minus 3 over 5 plus y sin alpha is 4 over 5 equals d. d is equal to 5. So the answer is 3x minus 4y plus 25 equals 0. This is the answer for the second. Om කරගෙන යන්න මම තව ගානක් මෙතන දානවා. You can do the third also, then try the fourth. මේක ඔක්කොම දැන් කරලා ඉවරයක් කරමු. Shall we see the answer for the third? If you have finished it. Number 3. This time we are given inclination of the line with positive side. See, this is alpha. And the perpendicular distance is 4. This distance is 4. This angle is alpha, but this is not the angle that we need. To write the equation in this form, x cos alpha plus y sin alpha equals d form, this is not the angle that we need. It is this. With the inclination of the normal. Inclination of the normal with the positive side of x axis. It is this that we need. So this is 90 minus alpha. And this will be 90 plus alpha. And that's the angle that we need, 90 plus alpha. And the distance is 4. So the equation is x cos, not alpha, it is 90 plus alpha, plus y sin 90 plus alpha equals 4. But you know that cos 90 plus alpha is minus sin alpha. Angle එකේ by alpha කියලා තියෙන්නේ නේ. Minus x sin alpha. This is minus y sin alpha equals 4. No, this plus sin 90 plus alpha is cos alpha. Sin 90 plus alpha is cos alpha. equals 4. So I'll take the term to the other side. Finally, the answer is x sin alpha minus y cos alpha plus 4 equals 0. That is the answer for question number 3. Balan Hardikula. Karina, you can try question number 4. Correct. එතනින් අපි මේ පාර්ට් එක ඉවරයි equation of a straight line කියන එක ඉවරයි මේක කරලා දාන්නකෝ බලමුද හරිද කියලා. Let's do the right one first. It's about two parallel lines. Two parallel lines, each of which makes an acute angle alpha with the positive side of x-axis. Two lines L1 and L2. You are given that this line L1 passes the point A in min. This line passes the point B, PQ. We need to find the distance between the two lines. So surely this has something to do with look at the also something to do with the theorem we learned last theorem, right? The last theorem number 6. To connect the theorem number 6 with this, we have to lay a normal from the origin and say the normal distance is some d1. Then produce it. You need the normal distance from origin to the second line also. You don't need to construct another normal, just produce it. That will equal to d2. Okay. Okay. So what we need is the distance between two lines. Say some d. Yeah, this is d. So d is equal to d2 minus d1. That's the key point. D is equal to d2 minus d1. හරි ඒක ඉතින් කියන කරන්නකො මම ආයෙත් පොඩි විනාඩි දෙක තුනක් දෙන්න ඉවර කරන්න බලන්න. This is what we need to find. මෙහෙම තියෙනවා පුළුවන්. එතකොට වෙන්නේ d1 d2 කියලා ගන්න වෙන්නේ. එතකොට මේක වඩා වෙනස් වෙයි. නේද? එන එක්ස්ප්‍රෙෂන් එක වෙනස් වෙන්න පුළුවන්. එහෙම වෙන්න නම් පුළුවන් බෑ කියලා නැහැ නේද? Then it's not d2 minus d1. You will have find d2 plus d1. එතකොට මේක වෙනස් වෙනවා පොඩ්ඩක්. To get this answer, you will have to take things like this. මොකද නේ ළමයි? Any success? Any success? කවුද කියන්නේ මම යටින් තිබුණොත් ට්‍රාන්ස්ලේට් මාරු වෙනවා. alpha එක minus වෙන්නේ නැහැ. alpha will remain the same. යටින් තිබ්බොත් බලන්න. alpha is the inclination of the straight line. to යටින් තිබ්බා නම් here is alpha. එතකොට මේක මොකද වෙන්නේ? මට උත්තරේ වෙනස් වෙන්නේ නැහැ. alpha, then this will become 90 minus alpha. 8 මම හිතන්නේ මේ ආන්සර් එක එනවා කියලා. ඕනනම් කරලා බලන්න. with d2. So 90 plus alpha. In this it's 90 plus alpha. Here this angle is, the angle that we need is 90 plus alpha. If you do it below the line, below the origin, that angle will be 90 minus alpha. ඔක තමයි වෙනස. එතකොට මෙතන plus minus එකක් මාරු වෙනවා. I think still there's a chance of getting this. බලමු ඔන්න. හරි. දැන් තව මේකට හදලා So we will find d1 and d2. First we will write the equation of L1 in the form we have the distance from the origin d1 and the inclination of the normal 90 plus L, right? So the equation of L1 is angle is 90 plus alpha. X cos 90 plus alpha plus y sin 90 plus alpha equals d1. But cos 90 plus alpha is minus sin alpha. Sin 90 plus alpha is cos alpha. Equals d1. So this is only the equation of the line, right? This is the equation of the line, but it is not the equation that we need. We need an expression for d1. We want to find d1. So how do we find d1 from this? This is the equation of the line. We need to find d1. What do you do to find d1? So you can find d1 by substituting this point. For x and y, x, y are the problems. So for x and y, we can substitute mn because this line passes the point A. Since it passes amn, from this you get minus m cos minus m x is m. So minus m sin alpha, y is n cos alpha equals d1. Okay. So similarly, you can find the equation of L2 also. Similarly, you don't need to find everything again. Similarly, not the equation of L2, we can straight away find d2 using this. Similarly, d2 is equal to instead of n we get p minus p sin alpha plus instead of n we have q cos alpha. And mechanical d1 better in the definitely. So d is the distance between them. D is equal to d2 minus d1, and better the like modulus, because we don't know whether d1 is greater than d2 or d2 is greater than d1. In our diagram, it looks like d2 is greater than d1, but it can be the other way around also. But d equals d2 minus d1, the modulus. So subtract them, you get when you subtract d2 minus d1, m minus p sin alpha, yeah, plus n minus q අඩු කරනවානේ minus අඩු කරනකොට මොකද වෙන්නේ? sorry මේක අඩු කරනවානේ 1 minus plus n minus n minus plus n minus q. But 2 minus 1, q minus n cos alpha. Make it mark කරන්න පුළුවන් නේ. So that will become that's what we need. And modulus. අර විත්මල් කියපු විදිහට පල්ලෙහාන් තිබුණා නම් මම නිකන් බලන්න try එකක් දාලා so d2 මෙහෙ තියෙන්නේ නේ. Angle is 90 minus alpha. Then d2 equals the equation of L2 will become x cos 90 minus alpha plus y sin 90 minus alpha equals d2. So that's x sin alpha plus y cos alpha equals d2. Then මේ point එක ගන්නවා වෙනවා p cos alpha. d2 equals x වෙනකොට p දානවා p sin alpha plus q cos alpha. දැන් ඔය දෙක අඩු කරමු. එතකොට එනවා d equals p plus m. මොකද p plus m නේ sin alpha plus q minus m cos alpha. මෙතන plus වෙනවා නේ අඩු කරනකොට plus q minus m මේක එනවා. හරි. මෙතන මොකද වෙන්නේ? So the answer changes. You don't get the same. Oh, m and the click man මෙතන plus වෙනවා. ඒක වැරදි නෑ, but you don't get the expected answer. එනිසා එහෙම ඇඳලා ගන්න එපා කියලා තමයි කියන්නේ නේ. Yes, that happens. Teran Lippmann. It's not wrong, but you don't get this answer if you do L2 below the origin. एक इतनी प्रश्न है तिरका में. So it can be plus or m plus or minus p here. Medial thing उतरेगा ना, you have to draw them the same place, the same side. माइनस දාන්න වෙන්නේ. ඔයා කියන එක හරි. ඔයා කියන එක හරි. ඒකට මයිනස් දාන්න වෙනවා. sorry. ඔයා කියන එක හරි. ක්ලික් මෙතන minus 90%. sorry. මට ඒක කල්පනා නැහැ. ඒකට මෙතන minus දාන්න වෙනවා. ඒකට මේක minus වෙලා මේක minus වෙනවා. Make a minus and a cos 90 plus alpha. This will become minus because sine minus theta equals minus sine theta. What's the name? Sorry, it's the name. I'm clear. Maybe we will do this. But that one is this. The second will change. It will be minus here and minus here. Method cos 90 plus alpha. That will be sine alpha. Method minus y. Sine minus theta minus sine theta. So that will be minus q here. You get p plus. Still p plus m and q minus. Minus. Still you don't get the answer. Minus q plus m. Still you don't get this. Instead you get plus minus this plus and plus here. එනිසා ඒක ගන්නේ නැතුව ඉන්න එක හොඳයි නේ. It's not wrong to take that below the origin, but you don't get the given expression, so it's a problem. Therefore, better we don't do that. Don't take it that way. No. Right? So with that we finished the first 6 theorems about equation of a straight line. Now further theorems on straight line. We discussed theorems on equation of a line. ළමයි මේ Thursday class එක මේ විදිහට පොඩ්ඩක් පරක් වෙන්න පුළුවන් ඉදිරි දවස්වලත්. ඒකට කමක් නැහැ නේද? ප්‍රශ්නයක් තියෙද? Thursday class එක ටිකක් පරක් වෙලා පටන් ගන්න. 6:00 6:35 වගේ වෙන්න පුළුවන්. 6:00 නම් වෙයි කොහොමද? ප්‍රශ්නයක් තියෙද ඒකට? 6:45 වෙන්න පුළුවන් ගොඩක් වෙලාවට. 6:00 පටන් ගන්න පුළුවන් වෙන්න පුළුවන්. කවුද ඉන්නේ ළමයි ඉස්මාල ඉන්නවා කවුද ඉන්නේ no problem කවින්න අපි හිටියනේ කවිෂා හිටියා ඔය කියන්නේ කවිෂා will it be a problem for Thursday right ඊළඟ සතියේ කීපෙදි පොඩ්ඩක් okay Right, now the theorem on straight line. First theorem, under this, theorem 1. In this, we are going to find the angle between two straight lines in Cartesian plane. We are given two straight lines in Cartesian plane. two straight lines with gradients m1 and m2. Two straight lines with gradients m1 and m2. You are given the gradients of two straight lines. We need to find the angle, the, in fact, the acute angle between them, right? Two gradients are sufficient to find the angle between them, right? So let's see. The theorem says if the angle is theta, acute angle is theta between the two lines with gradients m1 and m2, then tan theta is given by mod of m1 minus m2 mod of m1 minus m2 divided by 1 plus m1 1 plus m1 m2, right? So this is the theorem, right? We'll write it nicely. The acute angle, the acute angle theta between the two straight lines L1 and L2, of which gradients are m1 and m2, is given by tan theta equals mod of, this is the theorem, mod of m1 minus m2 over 1 plus m1 m2. So that is the theorem, right? Now let's prove it. Let's prove it. Proof. With this equation L1, this is the straight line L1, this is the straight line L2. This has gradient M1, this has gradient M2. You are given the gradient M1 and M2. And say this angle is alpha, this angle is beta. M1 is equal to tan alpha. M2 is equal to tan beta. Let's identify these vertices. You can see a triangle here formed by the two lines and x-axis. Let's identify the vertices A, B, and C. We want to find this angle theta. So it's all in geometry to start with. You know that beta plus theta equals alpha. The external angle is equal to the sum of two opposite inner angles. So theta is equal to alpha minus beta. From this triangle ABC, from triangle ABC, so we get theta equals alpha minus beta. And take tan on either side, and theta equals tan of alpha minus beta. So we have these two, right? Then we want to express this in M1 and M2. The thing to do is expand this. This is the formula. Expand it. Tan alpha minus tan beta over 1 plus tan alpha tan beta. And tan alpha is equal to M1 minus tan beta is equal to M2 over 1 plus M1 M2. And theta is the acute angle we have taken, but M1, M2 can be any numbers, so this can even be negative once you substitute. So, but if we are looking for the acute angle, then this has to be positive. To make sure that it's positive, we will apply modulus. But tan theta is greater than 0 for theta, the acute angle. We are looking for the acute angle. Therefore, tan theta equals apply modulus m1 minus m2 over 1 plus m1 m2. That's a proof. සිකුරාදා වන්දේ නම් මේ එන්න දුන්නේ දැන් දැන් කියලා ඉන්නේ සිකුරාදා එහෙමද හරි එහෙනම් මම බලන්න මම කරේ ඒකට තමයි කවුරුත් නැහැ example දෙනවා මම example දෙකක් කියනවා පොඩි කරගෙන යන්නකෝ බලන්න. කරගෙන යනවාද ළමයි? First question is easy. Answer number 1, n1 is the variant of the line, is the variant of the second line. So tan theta is equal to mod of n1 minus n2 over 1 plus n1 n2. n1 is 2 minus n2 is plus 3 over 1 plus n1 is 2, n2 is minus 3. So it's 5 over minus 5. It's equal to 1. So this gives the acute angle between them. The formula gives the acute angle. It has to be 45 degrees. Therefore, the acute angle between two lines is 45 degrees. But you have to find the obtuse angle. Obtuse angle between two lines is 135. 180 minus 45. So this is the answer for the first question. දෙවෙනි එක කරගෙන මම වෙලා දෙන්න draw diagram. Try to figure out the question. බලන්න ඔක ඇඳ හරිද කියලා ඩයග්‍රෑම් එක. So you are given some straight line y equals to root 3x plus 4. And there's a point A, 2, 3, 5. The two lines are inclined by 60 degrees to this line. We have to find equations of these two lines, L1 and L2. That's the task. හරි බලන්න මම ටිකක් කරලා දෙන්නම්. කරන්න. Yes, what do? We want to find the equation of L1 and equation of L2. About both the lines, we already have one data. There's a point in L1 and point in L2, right? So we know a point that L1 passes, we know a point that L2 passes. So if you want to find the angular equation of L1, it's sufficient to know the gradient of this. Gradient of this, or gradient of this, knowing the gradients, we have a method of writing the equation. Gradient and a point, we have a method, right? That is the third method, third theorem, or the second method. We can use that to find the equation. So now the task is to find the gradient of this and gradient of this. You can use the theorem that we learned. The angle between two lines, you can use the theorem to find the gradient of this. Say this one has a gradient, has the gradient 2 root 3. Say this is M1, and the angle between them is 60 degrees. So we can apply the theorem. Tan 60 equals mod of I like M minus M1 over 1 plus M1. Tan 60 is root 3. M is 2 root 3 minus M1. M1 is unknown. And M m dash m dash over 1 plus m. M is 2 root 3 m dash. Okay. And to get rid of the modulus, we introduce plus or minus on the other side. Okay. 2 root 3 minus m dash over 1 plus 2 root 3 m dash equals plus or minus root 3. So we get one answer, one solution for m dash when you take plus, another solution for m dash when you take minus. Again, m1 the other we will take as m2. You get both m1 and m2 at the same time. Solve this, one from plus, one from minus. And again, when it is plus, you get m dash equals root 3 minus by root 3 over 7. Then minus 2 root 3 minus m dash over 1 plus 2 root 3 m dash equals, we take minus m dash. Sorry, minus root 3. So cross multiplying, you get 2 root 3 minus m dash equals 2 minus 6 m dash. Getting it down 5 m dash equals m dash equals 3 root 3 over 5. Now the minus 3 root 3 over 5. So we'll take one of them as m1, the other as m2. We get two values for m dash. One will match to with m1, the other with m2. I will take with m1 be equal to this and m2 be equal to this. Now write down equations. Equation of L1, equation of L2, equation of L1. Kalau dalam kemudian equation of L1, we have coordinates of a point and the gradient. So y minus y minus 5 over x minus root 3. Y minus 5 over x minus root 3 equals the gradient. Gradient is this root 3 over 7. තේරුණා නේද? ලිප්මල්. තේරුණා නේද? අපි ළඟ tools ගොඩක් තියෙනවා. අපි අවස්ථාවේ ඇටියට ඒක පාවිච්චි කරනවා. එක tool එකක් කියන්නේ එක ගිහලා හැමතැනම දාන්න යන්නේ නැහැ. In a situation like this is what we use to write the equation. තේරුණා නේද? Seven y minus 35 equals root 3x minus 3. Like root 3x minus 7y plus 32 equals 0. That is answer for the right. That is answer. That's the equation of one of the straight lines. Same for the other. We still again have the point, the same point, but the gradient is different. Equation of L2. Same point, y minus 5 over x minus root 3. And the gradient is this, minus 3 root 3 over 5. So 5y minus 25 equals minus 3 root 3x plus 9. So 3 root 3x plus 5y minus 34 equals 0. So those are the answers. Equations of two straight lines. හරිද ළමයි? අපි දැන් ඊළඟ තියරම් එකට යන්න වෙලා නැහැ. අපි අද පාඩම මෙතනින් අපු ඔයගොල්ලෝ හෝම්වර්ක් දෙන ප්‍රශ්න ටික මම අර ට්‍රාන්ස්ලේට් කරලා දාන්න කර කරන් දැන් මම ට්‍රාන්ස්ලේට් කරලා තිබුණේ ඒක ටික. මම හිතන්නේ කරලා දාන්න හෝම්වර්ක් එකක් ටික පොතේ එක්සර්සයිස් එක ට්‍රාන්ස්ලේට් කරලා ගන්න. ඔයගොල්ලෝ කැමති නම් පොත ගන්න හොඳේ සිංහල මීඩියම් පොත. අරගෙන එක එක කරගෙන යන්න පුළුවන්. මම ට්‍රාන්ස්ලේට් කරලා දාන්න. ඔයගොල්ලෝ කවුරුත් බවක් මම මතක නැහැ. පුරාණ පොත ගන්නද? මම එක්සර්සයිස් වල තියෙනවා ට්‍රාන්ස්ලේට් කරලා දාන්න. හරි? හිතානින්දට දාලා කියන්න. right. එහෙනම් ළමයි අද ඔතනින් නවතිමු. විශේෂ කමෙන්ට් නැහැ නේ. තර්ස්ඩේ ක්ලාස් එක දිගටම 6:00 වගේ වෙන්නේ. මම අද පොඩි පුතා එක්ක ප්‍රැක්ටිස් කරනවා. උදේ ක්ලාස් එකේ වුණ නැටි ගිහිල්ලා ආයෙ ප්‍රැක්ටිස් වුණ නැටි කරා දුවගෙන ඉන්නේ මේ වෙලාවට තමයි. හරි? right. එහෙනම් ඔයගොල්ලෝ හැමෝටම උස්සන්නයි. good night. ඉවරයි ක්ලාස් එක.